Okay, ladies and gentlemen, so today in this video, I am going to very briefly discuss the two examples that were done in class today. And we're going to be talking about two things. One is reference angles, and two is how to calculate the exact value of trigonometric functions. To calculate the exact value of angles. Okay, so we're going to see first is finding reference angles, and the second thing is evaluating trigonometric functions for non-acute angle. More specifically, evaluating sine and cosine of special angle entities, uh, or evaluating function of special angle entities. So, reference angle. So basically, a reference angle is, and I'm looking for the definition here. Basically, is a reference angle of a it's the reference or which angle makes which special right angle makes reference to an angle that is not necessarily a special one. So, for example, what if I wanted to evaluate a trigonometric function of 210, what would be the angle closest to it that I can use? Likewise for 135 and for 422. So in order to find reference angles, we have to kind of take a look at or assume, first of all, that all angles are in standard position. So if we have an angle that is in standard position, we assume that the beginning or the initial side of the angle is right here, and the 0 and 360 degrees. So if we have an angle like 210, for example, we know that 210 or the terminal side of 210 is in the third quadrant. So in this case, we simply say that to find the reference angle, we subtract 210 minus the reference angle, or minus the alpha, or minus z, excuse me, minus z. And in this case, z is the angle that is closest to the terminal side. So in this case, if the terminal side of an angle is in quadrant 3, we say that z is here, and this is 180 degrees. So what we're going to do in this case is we're going to subtract 210 minus 180, and our answer is 30. So that means that the reference angle for 210 is 30 degrees. Okay. Now, if we look at 135, which is B, 135, assuming that it's in standard position, we know that this is our initial side, and 135, the terminal side, is located in quadrant 2. So basically, the terminal side of 135 is here. Now, which reference angle do we use? Well, we use 180 as well. And why do we use 180 and not 90? Or in the case of 210, not 270? Because they're located on the axis, and we are working with quadrants. So that's why we don't use those. Anyway, so what I'm going to do here then is I'm going to subtract 180, which would technically be the angle closest to 135, not 90, because 90 is on the positive y-axis. And we subtract 180 minus 135, and we get that the reference angle in this case is 45 degrees. So one thing that I want you guys to understand is that there can be an infinite amount of possibilities to determine reference angles, but at the end of the day, most, and because I don't want to generalize, but most of those angles will fall back on special right angles like 30, 60, and 45. Not always is that the case, like we're going to see here, but in most cases, that those would be it. Now, if we look at the last one, it says 422 degrees. So assuming that the initial side is still here, 422 degrees involves an entire rotation, counterclockwise rotation, because 422 degrees is positive. Later on, we'll see what to do with the angles that are not positive. So it's a little bit greater than 360. So that means because 422 is greater than 360, the closest reference angle, or the closest angle that we're going to do in this case, is to actually subtract 422 minus 360, given the fact that 422 is greater than one full rotation. And when we subtract 422 in this case minus 360, we get that our answer is 62 degrees. And that would be the reference angle for this exercise. So it's very easy to calculate the reference angle. Now what we're going to do is we're going to take this a step forward. And now we're going to evaluate trigonometric functions using reference angles, right? So we know, for example, the trigonometric, or we've studied the trigonometric functions, or the sine, cosine, and tangent functions of 30, 60, and 45 degrees. So based on that, we're going to use that information to calculate then to go on to our next topic, and we're going to do it right here real quick. So let me go ahead and erase this. And what we're going to be seeing now, and in your book, this is titled as Evaluating Trigonometric Functions for Non-Acute Angles. More specifically, to evaluate, it says evaluating evaluating trigonometric functions of special angle entities, or special angle exactly. So we're going to use what we just practiced in regards to the reference angles to actually go ahead and solve this exercise, this example that we're going to look at now. Okay, so let me go ahead and delete this. If you have any questions, you can always pause and rewind the video and listen to me explain this again. So let's go on to this next example, which is actually located on page 89, if I'm not mistaken, of your textbooks. So let's go ahead and do that. And what we're going to do is, it says the cosine of 210 degrees. Now, before we go into this, we have to remember that acronym or that shortcut. I think that's the better word. The shortcut that we used in our previous class, which is all students take calculus, meaning that in quadrant 1, all trigonometric functions are positive. Students, meaning that in quadrant 2, only the sine and the cosecant, which is the opposite of the sine, are positive. Take, which would be in quadrant 3, and in quadrant 3, it's saying that all trigonometric functions are negative except the tangent, and of course the cotangent, because the cotangent is the opposite of the tangent. And all students, and the last one was take calculus. And again, calculus is in the fourth quadrant, and it basically means that all angles or trigonometric functions, are negative except for the cosine and the secant, which is also found in quadrant 4. So based on this and based on what we practiced prior, let's find the exact value. In this case, we're looking for the exact value of the cosine of 210. Now I know that 210 is not a special triangle, and it's good that you graph 210. And the reason why you want to graph 210 is because remember that wherever that terminal side is located is going to determine if that trigonometric function is going to be positive or is going to be negative. So again, assuming that all angles are in standard position and the initial side of the angle is right here, then the terminal side is in quadrant 3. So that means that the first thing I'm going to do is I'm going to subtract 210 minus 180, because it's in the terminal side is in quadrant 3, and if the terminal sides are either in quadrant 2 or 3, we use 180 as our reference. So 210 minus 180 equals 30 degrees. Now 30 degrees, because 30 degrees is a special angle, I know the cosine of 30 degrees. So what we're actually going to do is look for the cosine of 30 degrees. Okay, now my suggestion is memorize it. However, if while you memorize it, you can look for the cosine of the special right triangles in your textbook. You can make reference to that. So the cosine of 30 degrees actually equals the square root of 3 over 2. So that means that the cosine of 30 is the square root of 3 over 2. But one thing that we have to, so I know that. Let me just write that down. The cosine of 30 is the square root of 3 over 2. However, remember that we are using the shortcut, the all students take calculus shortcut to determine the sign of this. So first of all, if we subtracted, or if we look at, the 210, we know that the terminal side of the 210 is in quadrant 3, meaning that the only trigonometric function in quadrant 3 that is positive is the tangent. So the exact value of the cosine of 210, and I'm going to write that down here, the exact value of the cosine of 210 is not the square root of 3 over 2. It's actually the negative square root of 3 over 2 because, as I mentioned a minute ago, the terminal side, give me 1 second, negative square root of 3 over 2. This would be my answer. Now, the reason why it's negative is, again, look at this. The cosine of 210, the terminal side is in the third quadrant, and I'm being asked to find the cosine. So if the terminal side is in the third quadrant and I'm being asked to find the cosine, that means that the cosine function is going to be negative, because in the third quadrant, the only positive functions are the tangent and the cotangent. So I know that 30 is my reference angle, which is, I calculated it by subtracting 210 minus 180. And I know, based on my knowledge of special right angles, that the cosine of 30 is the square root of 3 over 2. However, because the terminal side of 210 degrees is located on the third quadrant, that means that the function is going to be negative. So my answer is that the cosine of 210 is actually the negative square root of 3 over 2. Now, that brings us to the last example that we're going to look at now real quick. And in the last example that we're going to see in this video, it is telling us to find the exact value of the tangent of 495 degrees. So now, instead of looking for the sine or the cosine like we did a while ago, we're going to look for the cosine of, or the tangent of 495 degrees. So the first thing I want to do is draw that so that I know what I'm going to be using. So let's change the color real quick. Again, we're assuming that it's in standard position, so that means that our initial side is here. Okay. The second thing that we are going to do, ladies and gentlemen, is to find the reference angle. So I know that 495 is obviously greater than 360, so that means that this is a full rotation counterclockwise, because it's positive 495 degrees. And I know that 360 is here, so we would assume that the terminal side is going to be somewhere in the second quadrant. But what we're going to do to determine what is the reference angles, and sometimes you may have to subtract more than once. So we're going to say 495 minus Now we need to use, or some cases we might have to subtract more than once because we're using the special the special angles as our reference angles. So it's a possibility that sometimes you might have to subtract again. So I'm sorry, and I just realized that I wrote the wrong number. So 495 minus 360. And some of you are paying close attention to this video, you might realize that I actually wrote the answer. So 5 minus 0 is 5, 9 minus 6 is 3, and that leaves me with 135 degrees. However, even though 135 degrees is much shorter and brings me closer to my answer, I have to subtract that again. Now 135 degrees, that means that the terminal side is in the second quadrant, so I have to subtract 180 minus 135. Now I subtract 180 minus 135, and that's going to give me the answer that I'm looking for. And when I subtract 180 minus 35, my answer then is 45 degrees. So that means I'm actually looking for the tangent of 45. So the first thing I'm going to do is look for the tangent of 45. Again, we already studied this, but while you memorize them, you can make reference to them in your textbook. So the tangent of 45 degrees is actually 1. But what I want to know is if in fact the tangent of 495 degrees is 1, positive 1 or negative 1. So I know that the tangent of 495 degrees is 1. However, I need to make reference, or I need to look at my reference angle. And I know that when I subtracted 495 minus 360, it was 135. So that's in the second quadrant. And in the second quadrant, the only positive trigonometric functions are the sine and the cosecant. I'm being asked to find the tangent. So in that case, I know that the tangent of 495 degrees is negative 1. So I'm writing that down. The tangent of 495 degrees, 495 degrees, and 495 degrees equals negative 1. Hopefully, ladies and gentlemen, this video was helpful to you guys and can help you understand the practice problems that you need to do. So we'll see each other in our next class. Bye.